Alright, this is sdramThingZero. You can tell it's a prototype right now. It's on solderless breadboard, no less, and even with that rat's nest of wires, it is running at 30 megasamples per second. Amazing! So once it's on a printed circuit board, we're talking, 133 megasamples per second, 32 bits wide. Definitely doable. You can see the DIMM back here. I just wired it up on the back of an old motherboard. I just cut it out and desoldered all the components and then wired that up as a breakout board. That's all it is. We have a little bit of glue logic here, and it's just 7400 series chips. We have a crystal oscillator here running at 30 megahertz for the RAM. Another crystal oscillator here, 16 megahertz right now for an AVR. There's no reason that it needs an AVR specifically. I'm planning on actually moving it on to, I got my Pi Zero just a couple days ago in the mail. So the idea is a peripheral that uses basically only glue logic. Could be connected to your computer, to your Pi Zero. You could use an FT2232 breakout board like this one that's usually used for JTAG or that sort of stuff to connect it to USB. And it could be used for logic analysis. Obviously that's the goal of this particular one, but it has many other possibilities as well. Kind of what makes this unit unique is that all the actual sampling commands are handled by the RAM itself. So right now this processor is loading in the memory commands to tell it to read and write, but then when it actually does the sampling, this half of the memory will tell this half of the memory to do the sampling. So that's how you can get away with a much faster sample rate than your processor. Again, this one's running at 16 megahertz, or the SDRAM is actually running at 30. Here we go. You see boot, and then it detects the dimensions of the RAM, 32 megabytes. That's the size of the DIMM. It loads the free runner loop. Each one of these marks is 5 seconds, so it took about 20 seconds to load it. And then it finished, and then it started free running, and this is how many rows it goes through each second. So if you do the math, that makes sense because it's running at 30 megahertz, and there are columns per page, 256 columns per page, but there's 4 banks. Where's that? 4 banks. So that's 1024 columns per row. So 30 megahertz divided by 1024 is roughly that. So there you go. It is doing its thing. Part of what makes this what it is that it's doable with, pretty few parts and pretty much almost anything that's available in many hackers' collections, probably from most, if there's a electronic supplier nearby, then they probably have most of the parts you need. Here, this is the first version from years ago. This was before I was turning it into a logic analyzer, but you can see that it's wired up directly to the edge of the DIMM, which is something that's kind of nice. Okay, this is SDRAMThing 4.5, and actually it has more chips on it than the newest one, which is SDRAMThingZero, which I showed you first. But this one, if you look at the video for it, you can actually take out the processor like that while it's running, and it will still sample and repeat data. That's kind of the key factor. You see how these wires are wired back, so they go between the data lines and the command lines and address lines. You load it up first with the memory, and then half of the DIMM is used to control the other half of the DIMM. So this half of the DIMM is doing the sampling and repeating. This half of the DIMM is telling it to actually do that.